Welcome to Lesson 18, where Stage 04, Operate, officially begins. Over the next 6 lessons, we're turning a system that works and is protected into one that runs at scale, and we start where every serious operator starts: backup. Our tool of choice is Restic, a modern Go-written backup engine that's content-addressed, deduplicated, and encrypted by default, paired with S3 as our remote backend. By the end of this lesson, you'll have a tested, verified backup pipeline, because remember, an untested backup is no backup at all. Before we touch S3, let's get comfortable with Restic's mental model on a local repo. Think of it this way: one repository, encrypted and deduplicated, holds many snapshots, each a point-in-time capture. We install from Ubuntu's main repo, export the repository path and a password file. Never inline the password, ever. Generate a strong, random secret, then init. The first backup is full, around 1.2 gig in our example. Run it again and watch deduplication do its magic. 99% unchanged, 4 megabytes uploaded, done in under 2 seconds. That's the payoff. Local is a fine starter, but production demands off-host and off-region. A fire in your rack shouldn't take your backups with it. The beauty of Restic is that the backend is just a URL. Swap S3 for Backblaze B2, often 4 times cheaper for cold storage. Or SFTP onto a box you control, reusing the SSH keys we set up back in L13. And for the truly paranoid, REST server in append-only mode means a compromised client can add data, but never delete it. Same commands, same workflow. Only the repository string changes. Now, if you're shipping to S3, your backup user must never hold full S3 access. That's a ransomware blast radius waiting to happen. Restic only needs 4 actions: list bucket, get object, put object, and delete object for prune. Scope tightly to one host prefix so a compromised Web 1 can't touch Web 2's snapshots. Drop the credentials into an env file at chmod 600, wire it into a system one-shot service, that's our L10 callback, and pair it with a timer for nightly runs. Belt and braces, enable S3 versioning plus MFA delete on the bucket, so even if those keys leak, your backup history survives. Here's a trap that bites everyone eventually. Backing up a live database with plain Restic gives you torn pages in inconsistent state because files are read at different moments while Postgres keeps writing. The fix leans on our L9 LVM work. Checkpoint Postgres to flush WAL, snapshot the logical volume in a millisecond, mount it read-only, and let Restic back up that frozen view. Then unmount, drop the snapshot, and run retention. If LVM isn't on the table, PG base backup gives you native consistency the Postgres way. With consistency handled, the next problem is growth. Backups accumulate forever unless you tell Restic what to throw away. The standard 7-412 policy keeps 7 daily, 4 weekly, and 12 monthly snapshots. Roughly 23 restore points covering a full year. Remember that forget just marks snapshots. Prune is the expensive part that actually reclaims space, so decouple them. Forget nightly, prune weekly, and always dry run first. Tag your backups so databases keep longer retention than logs. And now the moment of truth, because a snapshot you've never restored is just optimistic storage. Run 3 tiers of drills. Weekly, pull a single config file like nginx.conf and diff it against the live copy. Monthly, spin up an LXD container, restore your Postgres backup, start the service, and run a real select to prove the data's there. Quarterly, do the bare metal scenario. Fresh cloud init VM, full restore, and clock the time from blank to booted. That wall clock number is your actual RTO. Aim for under 4 hours and back it all with Restic check. Read data to catch silent corruption before it catches you. Drills prove restores work, but you still need to know, every single morning, whether last night's job actually ran. The silent failure mode is brutal. 6 months of red exit codes nobody saw, discovered only when you finally need the data. So wire up 3 signals. Check the system unit's exit status as a L11 callback, Then export 2 custom metrics via Node Exporter's text file collector, the age of the latest snapshot in seconds, and the repo's total size. Then fire Prometheus alerts, backup tooled when age crosses 25 hours, and backup service failed the moment the unit flips to failed. With monitoring in place, step back and look at the bigger picture, because Restic isn't the answer to every backup question. Your recovery point and recovery time objectives should drive the tool choice, not the other way around. For a small Postgres, a nightly LVM snapshot through Restic is fine, 24-hour RPO, 1-hour RTO. But a high-volume database needs streaming replication with WAL shipping through PG back rest, pushing RPO under a minute. Application code lives in Git, not your backup repo. Caches you rebuild. And remember the 3-2-1 rule. 3 copies, 2 media, 1 offsite. Restic plus S3 gives you that for free. Now let's talk about the gotchas. 5 real incidents that have ruined real weekends. Number 1 is the classic. Backups ran for 8 months, the server died, and nobody could find the repo password. Fix it with quarterly restore drills, and the password stored 2 ways. Number 2, ransomware with stolen AWS keys runs S3RM recursive, and your repo evaporates. Enable S3 versioning with MFA delete, or run REST server append only. 3, never back up a running database as plain files. Use LVM snapshots from lesson 09 or PG-based backup. 4, put the repo on its own file system and run forget pullers prune in the same timer, or var fills and takes the host with it. And 5, restore across regions during a fire, and AWS hands you a $2,000 bandwidth bill. Replicate same region. Cost on a calm day is always less than cost on a bad day. So let's recap the 6 skills you now own. Restic basics, init, backup, snapshots, restore, and a weekly check that actually verifies repository integrity. S3, B2, or SFTP backends locked down with least privilege IAM and append-only protection. System timers doing the heavy lifting with on-calendar and persistent. LVM snapshots calling back to lesson 09 for consistent database backups. 7-4-12 retention enforced by forget and prune. And restore drills at 3 tiers, monitored by Prometheus alerts. 6 skills, 1 promise, a tested restore in place. Next lesson, we wire up the full observability stack, Prometheus, Grafana, and Loki. Lesson 18 is complete. Restic plus S3, LVM snapshot DB, 7-4-12 retention, and restore drills. All 4 boxes checked. Next up, we build the observability stack, Prometheus scraping metrics and firing alerts, Grafana giving you that single pane of glass, and Loki aggregating the logs we foreshadowed back in lesson 11. Your backups are tested. Now let's make sure you actually see what's happening across the whole system. I'll see you in lesson 19.